Hi, I'm Astronaut Randy Bresnik, and I'm trained as a military pilot. I was a F-18 pilot in the Marine Corps and became a test pilot. Well, it turns out test pilots are pretty good at this astronaut thing because we're used to unique situations and doing things that haven't been done before. One of those things is the science that we're doing aboard the International Space Station. We get so much variety. We've got over 300 experiments of different types going on the space station at any time. And we are there not necessarily to discover the new things and come up with, new compounds and new ways to do things, but we're there to execute the experiments that the really smart guys, the principal investigators, make here on Earth. And so we go up there and we follow the procedures and use their equipment that they've designed for zero gravity, and we execute the science that has been deemed to be important and useful aboard the International Space Station. Now, that's important because the space station, that's the only place where we have the zero gravity. And we're able to find stuff and come up with vaccines and crystal growth and tissues that we're able to grow up there that you can't do with gravity because it always deforms and breaks down the cells as they're growing. So what we're going to do right now is turn you over to Marty and Beth and my astronaut colleague Kate Rubins to go ahead and do some little experiment with DNA.
This is Kate Rubins. She is a NASA astronaut of expeditions 48 and 49.
Before becoming an astronaut, Kate was a scientist, and while in space, her and her crew worked on over 275 different science experiments.
Kate, you were the first person to sequence DNA in outer space. Can you tell us a little bit about that experiment?
Yeah, so we were looking at new technologies actually to determine the sequence of DNA in space. And so we used a small portable sequencer. It's about the size of your cell phone to actually determine the sequence of DNA. But before you can determine the sequence of DNA, you actually have to extract the DNA, right? It's inside the cells and you got to pull it out of the cells.
So what do we have going on here?
So it looks like we've got an experiment. We're going to use peas here. So peas are actually a multicellular organism. They've got DNA inside them. So you've got DNA inside you, but these peas have some DNA inside them, and we're going to get this DNA out of the peas here. So one of the first things that we're going to do is mix the peas with some cold water. And the next thing we're going to do is add a little bit of salt. And so that helps equilibrate our mixture and helps get some of that DNA out of the membrane. And that water helps get the DNA into solution. But the peas, the cells inside the peas, they all have a membrane, right? They've got some fiber. That's why everybody says eat peas. It's good vegetables for you. But we got to get rid of this membrane and this fiber in terms of getting the DNA from the inside. So one thing that we're going to do, and that we've done here already, is actually mix the peas with some detergent. And we'll let that kind of settle. And the next thing we're going to do is add a little bit of meat tenderizer. And we'll stir this. And then one of the ways that we can pull out DNA or precipitate DNA is actually with a little bit of rubbing alcohol. So the DNA is in a water solution here. We added water earlier. This is an aqueous solution. And when you add alcohol, it actually makes two different fractions. And so what that does is it helps us precipitate the DNA. All the DNA joins together, right? Because it wants to cluster together. And we can use that to grab all that DNA together, and hopefully we'll grab enough DNA together that we can actually see it. So I'll pour this into a glass here. And we didn't do this kind of thing on space station during my expedition, but we actually are flying some experiment hardware. It doesn't do it with a blender and some peas. It's actually some biological hardware that's going to do things like lyse the cells and denature the DNA so that we can look at DNA extraction on board the space station. So I'll pour in the rubbing alcohol, and we'll pour this in slowly here.
You can start to see it separating.
Yeah, so you can see these two layers that we've got here. So you see all this cloudy stuff, that's actually the DNA, so it's starting to precipitate, and we'll let that kind of settle. So you want to let the DNA gather together, and essentially we've broken open the cells, we've released the DNA, and then we've done this alcohol water mixture to separate the DNA and make it clump together. So let's take a look. It looks like we actually have a pretty good DNA mixture here. So we'll see if we can stir this around, and it looks like we can get a pretty good spool here. And this is kind of gross. You guys are going to love this when you do it in the classroom. It does look like a big ball of snot here.
But you can really see
But you
the
can
strands.
see all the strands of the DNA. And so these strands of DNA are microscopic, but when you get a huge amount clustering together, you can actually see the DNA. So if we were going to do this in a lab, the next thing we would do is put this in a centrifuge, and we'd spin it really hard so that all the DNA gathers together and forms a pellet. We can then clean up that pellet, and then we could put it into a sequencing reaction.
Wow. Kate, thank you so much. If you want to learn how to do this experiment in your classroom, be sure to check out our website.